Rob wrote to me about a problem encountered with 2.5 liter and 4.2 liter early YJ Wrangler chassis. It's an electrical issue from Rob. I can't thank you enough for your guide on tuning and troubleshooting Jeep 2.5 liter TBI 4-cylinder engines. You're welcome, Rob. I'm looking for the wiring diagram for this 2.5 liter TBI engine. The MAT, CTS, and WOT sensors all feed into the same harness. I'd like to verify back to the control plug that I actually have the right sensor going to the right pin. Also, tach gauges are intermittent or not working, including fuel gauge. I hear a rumor that the grounding block near the left shock tower is problematic on this vehicle. Wiring harness is very closely associated with the printed circuit board on the instruments. That instrument cluster and printed circuit board and plug harness and all of that are connected. Continuity tests with a voltometer are the best possible troubleshooting that you could do in this case. And there seems to be a relationship between the gauge and the printed circuit panel and the plug harness with regard to that. As far as the ground junction, any ground area could be a problem. You need to disconnect the battery negative cable before testing any circuits for continuity or ohms resistance. We're not looking for voltage, we're looking for resistance in a particular circuit. But beyond that, there's an additional test that's very handy. It involves an old headlamp. A lamp load test can be very handy. You take the headlamp and on a ground circuit, you use the ground to the headlamp to something like the junction block that you're referring to, Rob, where you think there may be a problem with the ground. And on the other leg of the headlamp, you use positive to a battery source, preferably away from the battery so that you don't generate a spark right at the battery. The idea is that you're checking the DC negative circuit to see if it has any kind of resistance or if there's a voltage drop across that circuit. The headlamp test, a dim lamp in this case, would indicate that you have a poor ground or a poor ground circuit. A little ingenuity in an old headlamp and some wire, you can run a lamp load test on that ground circuit that you're referring to. With any ground junction point, if it's near a painted surface, there's always a problem that rust or corrosion or even paint is interfering with the grounding. On any Jeep vehicle, I always make sure that there is a ground between the frame and the engine block, between the engine block and the body, between the battery and the engine block, and between the battery and the frame. If you're running heavy amperage circuits, a high output alternator for say a onboard welder or whatever, if that is the case, then make sure that all of your ground circuits have the same resistance capacity as the hot circuits do. In other words, use 1/aught cable or whatever is necessary on the ground side if that's what you're using on the positive side of the circuits. DC means the same amperage load on the ground or negative side that you expect on the hot or positive side. So keep that in mind. Use a lamp load test. Make sure surfaces are clean. Make sure that any junction block does not have corrosion, and if it does, make a point of disassembling the contacts and any terminal ends there, and making sure that you use your ohm meter to make a ground check from that junction block. And in this case, you'd want to make a check of continuity and resistance from that ground block all the way to the negative cable for the battery, checking the circuit for any kind of drop in resistance across that span of wire. Again, a lamp load test is indicative of resistance or an open or any kind of a voltage drop in a negative or a positive wiring circuit. This is 12 volt DC. Negative and positive have to have exactly the same amperage carrying capacity when it comes to cabling, wires, and so forth. In your case, Rob, it sounds like you need to check the ground integrity and lamp load test the ground circuits back at the fuel pump, the fuel gauge sender. Throughout the entire circuit, there may be poor grounding or poor continuity of grounds related to the fuel tank sender and the fuel pump. I would emphasize with an EFI system, throttle body injection, multi-point injection, any circuits or wiring related to the PCM, ECM, ECU, depending upon the manufacturer's description for the computer, require rosin core soldering, heat shrink tape of any junctions or splices that you make. Rob, you talk about splicing or repairing wires and wires that were crossed. Don't use buck connectors on those circuits. Some of those circuits are sensors and circuits that feed sensory input back to the PCM or the ECU. And in this case, you don't want to get signals that are lower voltage or a voltage drop. It will confuse the computer and you'll end up suffering for it in terms of engine tune. In general, I avoid the use of buck connectors or any connector where corrosion could form over time and break down a circuit or cause wicking of the corrosion up into the copper wire. So use plenty of heat shrink tubing. Try to emulate the factory insulation on a given wire. The layers of heat shrink tubing should be equivalent to the thickness of the insulation in that area. If you use rosin core, again, not acid core, but rosin core solder, clean things up thoroughly. You should have great connections and no problem with voltage drops or faulty signals to the computer.